level. For each of these levels, we have a different system which is operating. The lower level, we have transaction processing system. Middle level, we have what we call management information system. And for the topmost level, we have executive support system. The TPS are very detailed. Every minute detail is recorded. Then and they are for use for like the assembly line workers, the salesmen in the retail outlet, and they always have to be online and current. The middle level, they are summary report of transactions to enable the functional heads, and the top level, we have executive support systems, which are not in the form of reports, but they are in the form of graph. They are in the form of graph to just show the trend that is happening, like sales is going down, sales is stabilized, or sales is increasing, whatever. So these are the three levels. And beyond this, we also have another level of system which we call DSS, decision support systems, which fall somewhere between the middle and the top level. Now, these systems are not in use every day. They come to use when the management feels the need for it. When the management feels the need for it. And they are custom built to answer to certain problems or certain query that any management comes across. So we could have a credit analyzer which will enable us to decide whether we should give credit to a particular company depending on a certain factors. They could be models which will enable us to decide on how many warehouses do we need to keep with a certain budget in mind all across India. Now let us review it. Decision support system, I mentioned it yesterday also. The easiest definition is when you reverse the terms. It's any system which supports a decision. It is seen to be consisting of three components. One is the database, which holds data, which could be operational related data. They could be HR oriented, employee oriented data. They could be marketing oriented data, financial data. And the other is models. We build models pertaining to certain query, to answer to a certain query. Like in a marketing related model, what should be my advertising budget? In operation related model, how many supplies should we keep for this particular component? In an operational related model, or what is the level of inventory should we keep? So there could be certain models built. So there are three parts. One is a database which holds the data. The other is model base, which consists of various models that we use in different areas. And the third is the interactive software. They are all built into a single system under user control. Now, why we call it, then it is custom built for specific occasions. So if it is a certain variable or a certain query it is not built to answer that, it will not do so. I don't know how many of you can recall, there was a very prominent incident way back in 1984, Union Carbide tragedy, where there was a gas leakage which led to destruction, widespread destruction. Yes, gas tragedy way back in, I think, 84 in MP. So in this case, after this destruction took place, they built a DSS, a software, a decision support system, to make them aware of any leakage which takes place, and then they could take corrective steps. Now, what we mean by corrective steps is like they would identify at what rate where is the leakage, point of leakage, so that they could do something about it. At what rate is the gas emanating, the poisonous gas emanating? Then in which direction is the air flowing and taking the air, so that some kind of evacuation could be done in those areas. So they laid down various aspects, like the point where the gas leakage has taken place, the rate at which it is coming out, the leakage is coming out, the flow, in which direction is the gas flowing, and various other things. So it was so they built in these into the particular module, so it could enable you to take corrective steps, remedial steps. Now, just 6 months later, if I'm not wrong, this took place sometime in December 9th, this kind of a incident. And just they built a system within a month's time, a DSS. But another 4 months later, in April the following year, a leakage took place. But they were not aware of it.
Now, why is it so? Because when they built the DSS, they built the DSS in such a way that it would warn you about a leakage of 10 most poisonous gases. So there could be different gases which they ranked them most poisonous, second most poisonous, third most poisonous, like that. And this leakage was not among those 10 gases. So it was maybe the 11th or the 13th or the 14th one. So it was not built to answer to anything associated with this particular gas. So it could not reveal the leakage. And this is what we mean by custom built. So if it is built into the system to answer to a particular query, it would be doing so, else it would not be answering. So it is custom built for specific occasions or application. Like I said, that if you talk about suppliers, how many suppliers will you keep? If you keep 10 or 20 large number of suppliers,
Each supplier gets a small fraction of the volume of your purchase. But if you keep a lesser number of suppliers, each supplier would get a larger volume to supply to you of your purchase. He gets a larger volume of your purchases.
and then what happens? Your relationship with your supplier grows. How do we quantify that relationship? It could be in terms of price. So if he's offering me at a certain price, just because I'm giving him more volume of my work, he would charge a lesser price for me. It could be in terms of delivery time. Now he takes 10 days and he's really 10 days to supply. Now he lowers down on the delivery time and he supplies maybe in 6 or 7 days time. So what I do is, in my system, in my DSS, I set a relationship between the number of suppliers and the price, set a relationship between the number of suppliers and the delivery time.
So I vary the supplier. So supplier becomes my independent variable. I can make it 10, I can make it 5, I can make it 2. And price or delivery time becomes my dependent variable. So, but if I don't have a component like reliability of the supplier, the loyalty of my supplier, this DSS will not be able to answer to that.
So it depends upon whether that has been built into the system. If it is built into the system, it will be able to answer to that query. It will be able to answer to my query, else it will not be able to answer to that query. So this is what we mean by it is custom built to answer to a certain query. It is custom built for specific occasions. Now let us move. I think we took an example of supplier base and impact a reduction in supplier base has on the price, on the delivery time, on the loyalty of the supplier. So whatever the variables they have decided upon, it will be able to answer to only that, not beyond that. Not beyond that. Now let us see the 4 methods. They are what if analysis, sensitivity analysis, goal-seeking analysis, and optimization analysis. In a what if analysis, we see how the change in one variable, the independent variable, affects the other variable. Like if we increase the advertising budget, by how much is our turnover going to increase? How much would our sales increase? So that's one thing. If I increase my advertising budget, but how much will my sales increase? Second is the sensitivity analysis. Under sensitivity analysis, we see how we go on repeatedly changing the independent variable and see the effect on the dependent variable. So how repeated changes to a single variable affect other variables. How repeated changes to a single variable will affect the other variables. So this is sensitivity analysis, like how by repeatedly increasing, say, budget, how it is going to increase my sales turnover. How if I go on increasing my sales budget, say it's 1 lakh of rupees, I go on increasing by 10%, another 10%, and we go and see the impact it has on the sales. So one is what if analysis, the other is sensitivity analysis. Third is a goal-seeking analysis. In a goal-seeking analysis, we go on varying the independent variable till a final goal is reached. So we decide on the value of the dependent variable.
We decide on the value of the dependent variable. So say our dependent variable is $1 million. So we go on increasing our advertising budget till we reach that $1 million target value of 1 million.
And last is optimization analysis. It is finding an optimum value for selected variables given certain constraints. like what would be the best amount of advertising given a certain limited budget and a limitation of a choice of media. So we can put constraints. We can put constraints on how much we can spend on advertising. We can put constraints on our choice of the media, on which media we can advertise in. We cannot go beyond the print media, say for instance. So there are four methods. So DSS is a system which answers to certain query. It supports decision making. It consists of three components: the database, the model base, and finally an integrated software which accesses the data, makes use of a model, and advises the management as to what to do. There are four. We took the case of, it is custom built for specific occasions, so it will be able to answer to certain query only if it is built into the system. We took the example of Union Carbide gas tragedy in Bhopal, I think 9th of December 1984, and so they built a DSS to make them to caution them of any leakage. But just 4 months later, in April, when a leakage took place, it could not identify, simply because that particular leakage of gas was not built into the system to answer. So that's what we mean by custom built. So that variable should be incorporated in the model, else it will not be able to answer. Now there are four techniques that we use. One is what if analysis, where a change in independent variable, how it changes affects the dependent variable. Sensitivity analysis, we go on repeatedly changing the independent variable to see its impact on the dependent variable, on the dependent variables. Third is goal seeking. We go on changing till the independent variable till the final goal that we have in mind is reached. And last is optimization technique, finding an optimum value for selected variable given certain constraints. Constraints could be you cannot go beyond the print media, you cannot go on beyond a particular budget limit. So that is DSS, and DSS falls somewhere between the middle and the top level, somewhere between the MIS, Management Information System, and the Executive Support Systems. Now let us move on to yet another kind of a system, a specialized system, which is used by organization to help them take decision. Now this is what we call an expert system. It's a knowledge-based information system. It's a knowledge-intensive program. It's a software, and it's a knowledge-intensive program which uses knowledge about a specific application area. It could be about army. It could be about medical science. It could be about the soil, the constituents of the soil. And this expert will answer to any query related to this particular specialized field. So it's a knowledge-intensive program, or it's a knowledge-based information system which uses knowledge about a specific application area, and it acts as an expert consultant and advises the end users and answers questions in a very specific problem area, a very focused area. Like it will not answer to general medicine, but it will answer to maybe a specialized disease. So it's a very highly intensive, knowledge intensive program. Now, like human beings, it will make inferences about the knowledge, and this knowledge, where it is held into what we like we had a database. Here we have a knowledge base. It has a knowledge base, and in this knowledge base, it also explains how it is using the knowledge to come at a particular decision. In a DSS, it does not do so, but here they will even give you the reasoning that they have used and how they have come to a decision. So expert systems are highly knowledge intensive programs. They are software programs that we write for answering, which will give you a consultant advice, which will give you an advice like an expert and tell you what to do. It also explains why it advises you this way, how it reached to this particular decision. And just like a human being thinks, it will also use the thought process of a human being. So expert systems are very specialized systems. They are very specialized software programs that we write, which imitates the way a human being would work. So his reasoning, analogy, his reasoning strategy, how a human being is thinking, the same pattern the software will adopt to the same thinking pattern it will adopt, and it will give advice, consultant advice, to the user.
So they are knowledge intensive programs. They use a reasoning strategy which any other human being would be using. There are highly specialized programs, and they give you advice as to what to do. They give you expert consultant advice in a specified domain area, in some area of expertise, in some area of expertise. So just like a human being would behave, even this expert behaves in the same way. So we say they are computer programs that emulate human behavior. They are computer programs that mimic or emulate human behavior. So this is the simplest definition we give of expert system. It is any system, any computer program that emulate human behavior, any computer program that mimic human behavior. So it is human behavior which they try to mimic, which they try to emulate. How I think, it is going to use my thinking strategy, my thinking pattern. Now, it has various uses, particularly in the scientific field, like oil drilling. Just by testing a little bit of the soil in that area, it will be able to tell you whether this point is rich in rich. It has a rich oil base. It is used in geological survey, medical sciences. Now, there are certain experts like dendral. Dendral is used to identify the structure of chemical compound. It is used to tell you the structure of a chemical compound. Prospector,
it is used to identify sites for drilling or mining. So when you test the soil of that particular area, it will tell you, the expert will tell you whether it is a oil base or not, how much quantum of oil this particular area would be having. The third is knife. It's a short form for knowledge, KN for knowledge, I for information, F for fusion, E for exchange. It's it's a short form for knowledge, information fusion, and exchange. KN is for knowledge, and I for information, F for fusion, E for exchange. This was used extensively in for taking military decisions. The soldiers in the US made right military decisions, so they could assess what is the number of people, soldiers on one area, and they would therefore decide, if I need to send so many soldiers in this particular area, how much food needs to go, how much arms and ammunition needs to go in that particular direction, And yet another which is used in medical science is mycin, which is a large expert used in medical science to for identification of uh, infection in the blood, and a disease which we call meningitis, which is a disease of the brain. So it has extensive scientific application.
dendral is one which is used to identify structure of chemical compound. Prospector is used to identify sites for drilling or mining operations. Uh, Knife has been used in the military services, which is
Knowledge and information fusion exchange. It is used by soldiers in the US to make right military decisions,
to decide on how many soldiers I need to send to the northwest direction. When so many soldiers are going, how much arms and ammunition needs to be sent there, how much food, water, etc. needs to be sent in that direction.
and mycin, which is a large expert from medical science. Now, mycin was developed way back in 1970 by Stanford University, which give you consultative advice on bacterial infection in the blood and meningitis, which is a disease of the brain. And just like a doctor would identify whether the person has meningitis, his reasoning strategy, the same strategy was used by the physician. Same strategy is used by the expert. So they talk to the expert, they talk to the physician, and they try to interpret his reasoning strategy. So expert systems help to diagnose diseases. Responsive physicians were interpreted to diagnose the disease. Now it is how it worked is they would basically interact with
The expert would ask certain question. Now, whenever a patient goes to the doctor, it is because he is having some problem.
this problem is actually he is not able to identify the problem. This problem is actually a symptom. Symptom. If I'm having body ache, I'm having headache. It's a symptom. That's not the actual cause. That is not the actual problem. So that's just a symptom that there is some problem with me. I have a migraine every day. I have a headache every day. So that indicates that I have a problem. So we go with a certain symptom to the doctor.
We don't go and tell him, okay, this is my problem and this is the disease I have. We just say that I'm feeling feverish. So that's a symptom. That's not actually the problem. So using the symptom, we go to the problem.
And when you'll be discussing cases, this is what happens. Sales going down. That is not the problem. That's a symptom that there is some problem in the organization. There is a problem that we are selling defective products. There is a problem that we are not able to deliver on time. There is a problem that there are many competitors who have come up offering good goods. So we work with the symptom. Even in cases, the problem is never given. It is basically the symptom. It's a symptom. Sales going down. It's a symptom that something is wrong somewhere. So when I'm having headache, it's a symptom. It's not the problem.
It's a symptom that something is wrong somewhere. So what does a patient do? He gets a headache. So he goes to the doctor and he says, oh, look, I'm having headache, and it's really bothering me and not able to concentrate in my work.
And then I'm fidgety and I'm just not able to concentrate, and I need to sleep and I need rest or whatever. So he goes with a certain symptom that, look, I'm having a headache. Now, what does the doctor ask you? The doctor in response says, how often do you have it? Is it very frequent? Do you have it daily? And then I say, is it very severe? So then I say, well, it's not severe. It's a kind of a slight migraine which is there throughout the day. Or let's say I say that, no, it's very severe at the end of the day. Morning I'm fresh. By the time I wind up with my work at 5 o'clock, I get a severe headache. So I'm. What is the doctor doing? He's in fact interacting with me and taking out more information from me. Maybe the next, and I tell him, oh,
It's a slight migraine throughout the day, and I have it even when I get up in the morning.
next question maybe he asks me, is it associated? Now, which part of the head do you have it? Do you have it on the forehead? Is it the nasal of the bridge? So maybe he wants to find out whether it's a sinus or it's some other problem, or it's at the top of the head or the back of the head. We just say headache, but maybe the area where the ache occurs or the discomfort occurs differs. It could be the nasal bridge, it could be the forehead, it could be top of the head. So he asks, which part of the head do you have this headache? I answer to his query. Then maybe the third question that he asks me, is it associated with any other feeling, like a nauseatic feeling? You get a nauseatic feeling, a weakness or something like that. So he's trying to associate this headache with something else. So how did it begin? I began with a symptom. I went to the doctor with a symptom that I'm having a headache. He asks me, which part of the, he asks me, is it frequent? Is it a small migraine, or is it very severe headache? So I said, no, it's a small migraine which persists throughout the day. Next question, he asked me, which part of the head do you have it? So I tell him it's on the forehead, not on the nasal bridge, but on the forehead. Then the third question he asks me, is it associated with any other, feeling, nauseatic feeling, a weakness, something like that? So what happens? Just like the physician is asking me, the system, the expert would also ask. How? In the form of a MCQ, a multiple choice question. Which part of the head do you have this? No, is it frequent? Is it a migraine throughout the day? A. B. Very severe at the end of the day? C. It's very severe at the end of the day? C. It's very severe throughout the day? D. None of the above. So what I do, I tick. It is a slight migraine throughout the day. The moment I take that, the next question comes. A. Which part of the head do you have this headache? A. Forehead. B. Nasal bridge. C. Top of the head. D. Back of the head, and so on. So I tick on, say, forehead. Then the next question comes. Next question pops up saying, is it associated with any other feeling? A. Nauseatic feeling. B. So and so. Then factual questions will arrive, like, what is your age? Because if it's a pediatric group, 12 and under 12, the dosage is going to be different. It will ask you other factual question. Are you reactive to any of these drugs? A, B, C, D. So just a physician would be asking you the same kind of queries the software will be asking you. The expert will be asking you. And what has the expert done? On consultation, by interacting with me, it has taken out so much information from me, and in the end, it gives you an answer. Do this, take this medicine so many times a day, or whatever. So this is how an expert works. This is how a
Mycin worked. So it was developed in Stanford University in 1970 for consultative advice or expert advice on bacterial infection in blood and meningitis. The response of the physician was interpreted to diagnose the disease, and in expert systems help basically to diagnose the disease. Now, how it worked? It is an interactive software. It interacted with you and took up extracted information from you. It extracted information from you, and the sequence in which the information was collected was different. It did not start with maybe, are you reactive to any drug? It started with getting more information about the symptom that you went about with, and finally gave you a decision. So just like the reasoning strategy a human being, a physician would have used, here the expert has used it. Now, what basically is an expert system? They are development from the research in AI, artificial intelligence, which provides information on how to analyze a problem and develop search strategies for its solution. Develop search strategies for its solution.
Now, there are three stages of development. First stage is what we call natural language processing. Second stage, robotics. And the third stage is what I'm discussing now, that is of expert systems. First stage is a natural language processing. Second is robotics. And third is expert system. Now, natural language processing basically is a design and development of computer programs which understand and respond in languages known by human beings, like COBOL and Fortran. COBOL is common, CO for common, B for business, O for oriented, L is for language. Common business oriented language. Fortran is for FOR is for formula, Tran is for translation, formula translation, where it uses syntax like find, warehouse, where floor is equal to 3. So we're using terms like find, we're using terms like floor, we are using terms like where. So these are syntax that we use, common language that is generally used by human beings. Now, further development was robotics, which are basically visual and tactile programs. Visual means a program of sight. Tactile means a program of sight, a program of touch, which observe changes in the environment and react accordingly. So, a visual program is a program of sight. So they see some change in the environment and respond. Tactile program is a program of touch. You touch a particular point, so a reaction or response comes. Now these robots, they do the DDD, dull, dirty and dangerous work, and CBR, complex, boring and routine work for human beings. So they do the dull, dirty and dangerous work, or the CBR, complex, boring, routine work for human beings.
Like in Japan, they use robots. So human beings are not working there. So when a robo sees a customer enter, it opens the door. It opens the door for him. The customer enters,
Moves in, the robo comes and pulls out a chair for him to be seated. Then a robo presents a menu card, and on the touch of a particular point, it will respond and get you the food that you have ordered for. So they do the real boring work. So you're approaching a restaurant, they open the door for you. When you enter the restaurant, and you go to a table, they pull a chair for you to be seated. You touch a particular, so they observe changes in the environment and react accordingly. Touching a particular point would mean that they would get certain select items for you which you have ordered for. Similarly, the dangerous work, like we have warehouses which is at a height of say 20 or 30 feet. The ceiling goes to that height. It is difficult for human beings to take up a large equipment or a box and stack it there. So what they do in warehouses, they have these robots which can clasp the particular what do you call item, box, heavy box which you want to be placed, and it can extend its arm till it reaches the it can extend its arm till it reaches the ceiling, and it stacks that box in the particular ceiling. So it does the otherwise very dangerous work where the human being will have to climb stairs to stack that item or even pull out that item from there. So when you need that item, again the robo will extend its arm, uh, clasp that particular item,
and bring it down for you. So they do the DDD, dull, dirty, dangerous work, CBR, complex, boring, and routine work for human beings. Then the level of development, third level of development is what we call expert systems, which we have discussed with an example, that of mycin, which emulates human expertise and emulates the thinking pattern or the reasoning strategy that any human being uses to come to a decision, and advises the human beings to do accordingly. So these are basically development in the area of artificial intelligence, wherein the first level of develop it has expert systems. Our development or researches in the area of artificial intelligence has led to this, and the stages of they are highly knowledge intensive programs which are developed emulating the pattern of thinking that any human being does.
The stages of development are natural language processing, which is design and development of computer programs that understand and respond in languages known by human being, like COBOL, which is common business oriented language, and Fortran, formula translation. Second is robos, which are visual and tactile programs that note changes in the environment and react accordingly. And the last is expert systems, which we are discussing today, which basically are interactive software which emulate human beings, and they are highly knowledge intensive program. There are we will discuss the components and types of expert system, the components and its usage in management science in my next class, which will be on Tuesday, because I think Monday we have a meeting scheduled. So yet I will let you know by Sunday. Any query students have on DSS or on anything that we have discussed so far, that we have discussed in expert systems? Yes, any query students have? Yes, I can see some names. Arma, Bano, Yatindra, Shameen, Mohammed
No,
Adil.
ma'am, I don't have a query.
Okay. Vanshika, Varshni, Zaib, Siddiqui. So I can call it a day. I will let you know. I have a meeting scheduled on Monday. If it takes place, I'll let you know whether I'll be able to engage class or not on Monday. The rest of the components of expert system, I will cover in the next class. Thank you so
Okay,
much.
ma'am. Thank you so much, ma'am.
Okay,
Thank you,
ma'am.
ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Ma'am, can you please share the